Okay, this drawing is trying to describe a new method of taking torque down a lifter line from the likes of, say, if you had a daisy kite spinning up here, and further up the line you'd have a lift kite way up there, um, somewhere up high. If we decoupled that lift line from the lower part of the lift line, so it was allowed to spin, say, about down there, um, below here you'd have your daisy spinning this lift line. So in this part here, what we have is a sort of a ladder arrangement with pipes over the ladder. Now, you've got twisting going to be induced on that ladder, and to describe that twisting, you've got the intersection of how I've worked it out is the intersection of that radius of the post and the tube up there gives you that line, this line, that green one. And so that's the possible paths that the steps, I guess you would call it. It looks like a ladder, a rope ladder. That's what they could follow. When it's come round far enough, that ladder gets to about that point there. So that's when it's just gone past 45 degrees there. It's starting to compress this element here. So a normal rope ladder without this extra tube in the middle. Now remember, this whole thing is going to be spinning. A normal rope ladder would, at this point, just keep compressing. It would keep going all the way down like that. If there was much more compression on it than, much more torque on it than there was a lift force coming from the daisy, as it would be in this case. Now, the daisy is going to have a bunch of drag, and it can be set on the swivel up here, so we can have a fairly well fixed amount of pull on here. Or there's also a further possibility also of having a fixed setting daisy on a not spinning line with bearings in these, but that's going to be more draggy because of all the bearings in the transmission, so we're not considering that one at the moment. One advantage it would bring, however, would possibly be kicksale steering or lift kite steering through coaxial variance in the tension of 2 or 3 or 4 different lines going up the center. However, like I said, we're not considering that one just now. The dynamics of the situation are really quite tricky to get a grasp of, as there's so many fluid variables. You see in red here, I've got the line that's going to be most tensed as this moves around. That's going to be it seems to be whenever the line dips underneath, according to the modelling I've drawn here and the way I've done it, that's going to be the situation where it's always going to want to straighten out the curve that is induced by wind drag and gravity in the line. So it's often on the bottom that, well, it's drawn in red here, but that seems to be where it'll want to fight back. Now when this is twisting, I don't know, is there going to be some jumping induced on the line, but it's a very interesting dynamic that as this tightens up due to torque being put on it and wanting to be held high, we're going to be able to resist that in the line, whereas before you couldn't, as this would have been a soft area. As that goes down now, that's going to meet these floating, these elements float on top of that pipe. They are able to slide up and down. They'll be pushed down by these, and that'll rigidize at that kind of point there. I've gone a bit past the 45 on that one, but yeah, from here you can see that that would be able to transmit torque. We just have to now work out the various strengths of um, tubing, how much compression that's going to take compared to how much torque is put through, how much weight how much weight everything's going to be. There's a few ratios throughout this. We're going to have to work out like the step to length sizes. Is it better to have wider steps at the ends? Where you're taking out from the likes of a daisy and going down into transmission, as depending on the length of this, how many steps you've got going along, would it be better going wider at the bottom, or taking it again narrower? It's going to be the same speed either way. The torque transmitted, well, because of the leverage from a longer step to a shorter one, is that going to be an advantage? There's quite a few things still to work out and lots of optimization needed. So I'm hoping to build a model in the next few days and start some testing, get some ideas, actually how it feels, how it works throughout it. As usual, it's an open source hardware project, CC 4.0 NCBYSA. Join in, let me know if you need any files or anything to help work on it. If you get any suggestions, any hints and tips on how the modelling is compared to real world or anything like that, yeah, please help out. In order to keep transmitting torque down, I'm pretty sure you're going to want to keep these sticks as wide as you can all the way down. You can see you're losing a bit in that distance there of the turn this one's going to have on here, because it's not going out the full distance, perpendicular to there. So yeah, you don't want to shorten them either. I don't reckon that wouldn't help an awful lot. Again, still not sure, but maybe shortening this first stick so that it is actually perpendicular to the line force there. Might work once that's rotated 40, 45 or whatever angle we go to.